It is given the next information. In this question, you will use vector methods to determine whether aircraft are obeying air traffic regulations. The base of an air traffic control tower at an airport is taken as the origin of a coordinate system, and aircraft's position is given by the coordinates x, y, z, where x and y are respectively the aircraft's displacement east and north of the tower, and z is the vertical displacement over the aircraft above the base of the tower. All displacement are measured in kilometers. At 12 o'clock, two aircraft A and B are at the points P with coordinates 100, -82 and 10.7, and Q with coordinates 215, -197 and 10.7 respectively. So A is at point P with coordinates 100, -82 and 10.7, and B is at Q with coordinates 215, -197, 10.7. A. Find the distance between the two aircraft at 12 o'clock, 2 marks. So we need just find the distance between 2 points P and Q. And how to find the distance between 2 points? Just applying the formula. It is given in the data booklet, and formula says that it is equal to square root x2 minus x1 squared plus y2 minus x1 squared plus z2 minus z1 squared, and it becomes square root 100 minus 250 squared plus negative, so 100 minus 215 squared plus negative 82. Notice that it becomes minus negative, so plus 197 squared plus 10.7 minus 10.7, so plus 0 squared, and it becomes 163 kilometers. The two aircraft are flying along the same straight line flight path with B behind A. They both have the same constant velocity of -640 kilometers per hour. B. Find the speed of both aircraft. So if velocity is it's a vector and it's -640, 0, and we know that speed is just the magnitude of the velocity vector, so it's square root of 640 or -640 squared, because squared is positive, so it doesn't matter, -640 squared or 640 squared plus 640 squared plus 0 squared, and it's just 640 root 2 kilometers per hour, or it's 905 to 3 significant figures kilometers per hour. And it is also given that they are moving in the same straight line. B is always behind A, and they both have the same speed. The next. Air traffic regulation states that if two aircraft are on the same flight path, they must be always maintain at least a 10-minute gap between them. If at any time two aircraft are too close, they are said to be in conflict. C. Find the length of time it takes B to reach point P from point Q. B starts at Q, A starts at P, and hence state whether the two aircraft are in conflict, 3 marks. So since they are moving with the same speed, there always be this distance qp between them, and we need just time required v to travel this distance. So time is qp, distance divided by speed, and it is equal to, what is qp? It says this answer 163 kilometers. Speed it's 640 root 2 or 905 kilometers per hour, and it is equal to 0.180 hours, or we multiply by 60 to get 10.8 minutes. And since 10.8 is greater than 10, hence not in conflict. D. Write down RA, the position vector OA, t hours after 12 o'clock 1 mark. So position vector of any point, it's the position vector of the starting point. For A it's point P, and since it is required the position vector and coordinates of a vector, it's the coordinates of the point P minus the coordinates of the origin. But since origin is 0, 0, 0, we get the same numbers as for just a point, but it's coordinates of a vector, but numbers will be the same. So for P it's 100, negative 82, and 10.7 plus t, and velocity vector negative 640, 640, and 0. So there is the origin somewhere, and position vector at any moment of time. RA is given as position vector of the initial or the starting point, it's P, it's this vector, plus velocity vector multiplied by some scalar constant, which is t, and hence we can get any point on the line of travel. Next, if two aircraft are not on the same flight path, air traffic regulations state when the vertical distance between the two aircraft is less than 300 meters, the aircraft must be more than 10 kilometers apart. When the vertical distance between the two aircraft is at least 300 meters, there are no restrictions. The air traffic controller notices an aircraft C flying on a different flight path but close to A. The position of C t hours after 12 o'clock is given by negative 400, negative 41, 9.1 plus t. It's the same t because we start at 12 o'clock. For another problems, there may be required indices because two objects may be at some point at different moments of time. But here, time it's the same. These t values have the same values because we start at 12 o'clock for both, and negative 140, 604, and 2. And EI finds the two values of t at which the distance between A and C is 10 kilometers, 5 marks distance. So if R8 position vector at any moment of time OA and RC position vector at any moment of time for C. We can see the distance between two aircraft can be represented as the difference of two position vectors RC minus RA as a vector, or RA minus RC, it doesn't matter, and magnitude of this vector, it gives the distance between two aircraft, and we need this distance to be 10 kilometers, and we know that magnitude of a vector is what is square root of the sum of squares of its coordinates. And let's find a vector RC minus RA firstly, and RC minus RA as difference of two vectors. It just difference RC, it's negative 400 minus 140 t minus 100 minus negative 640 t, and you can just simplify it, and the same for y coordinate and for z coordinate. So to find this difference, it just x coordinate over vector for C minus x coordinate for A, and y coordinate for C minus y coordinate for A, and same for Z. So it becomes 500 minus 500t minus 41 plus 36t, 1.6 minus 2t, and it's this vector at any moment of time, and the magnitude or the length of this vector becomes square root of the sum of squares of its coordinates. So it becomes 500 minus 500 t squared plus negative 41 plus 36 t squared plus 1.6 minus 2t squared, and we need this distance to be 10 kilometers. And just using a calculator, you may consider two functions, the left hand side and the right hand side, which is 10, or you may square both sides to consider the left hand side without square root and to be equal to 100, or you may consider only one function, which is the left hand side minus 10, so the right hand side is equal to 0, and to solve such an equation we need to find zeros. If you consider the left hand side and the right hand side, which is 10, you should consider you should find the point of intersection. So I consider the next square root of this expression minus 10, and hence the right hand side is just 0, so I'll plot only one function, this function, and I need roots of this function, and we need window, and you can see table, and you can see that 0 is positive, 1 is negative, and 2 at axis 2 we can see that y is also positive. So a function changes sign about 0 and 2. So when we set window, I enter x from 0.5 to 1.5. I need to see y is 0, so in general it doesn't matter y from what to what value is. And we can see graph, and I need 0, so I choose calc 0, left bound, and right bound, enter, guess, enter. So the first root is 0.983, and do the same for this point. So again, calc 0, left bound, right bound, guess it's 1.02, and you can see that in between these zeros function is negative. So T1 is 0.983 to three significant figures, and T2 is 1.02 hours. Hours, oh, just each. So I find the two values of t at which the distance between A and C is 10 kilometers. 5 marks done. It is given that the distance between A and C is less than 10 kilometers only between these two values of t. Yeah, and we can see directly from a calculator that between these two values function is negative, so distance between two aircraft is less than 10 kilometers. I determine whether the two aircraft A and C will break the air traffic regulations if they continue with their current velocities. Justify your answer, 5 marks. And regulations states that when the vertical distance between the two aircraft is less than 300 meters, the aircraft must be more than 10 kilometers apart. When the vertical distance between the two aircraft is at least 300 meters, there are no restrictions. So restrictions are 300 if a vertical distance is less than 300 meters, so distance between them must be greater than 10 kilometers. So there may be a few ways how to solve this problem, and distance delta r is less than 10 kilometers when t is in between 0.983 and 0.2, and we can just find a time interval or intervals when distance in height is less than 300 meters, and vertical distance between them is just that coordinate of this vector, so 1.6 minus 2t, and the magnitude, it's since it's only one coordinate, it's just usual absolute value is let's consider to be less than 300 meters. So since we deal with kilometers and hours, it must be less than 0.3. And how to solve it? We can consider double inequality, 1.6 minus 2t to be should be greater than negative 0.3 and less than 0.3, or you may consider simultaneous inequalities. 1.6 minus 2t is less than 0.3 and 1.6 minus 2t is greater than negative 0.3, and you should take intersection and at the same time not add solutions, but you should take intersection. And actually, why do we consider such two inequalities? If absolute value is less than 10, so x should be in between from negative 10 to 10. If x, the absolute value of x is greater than 10, so x may be greater than 10, or x is less than negative 10, and absolute value of x to be less than 10, so it's in between negative 10 and 10. So here it becomes, we subtract 1.6 everywhere, and divide, so it's negative 0.3 minus 1.6, and negative 2t 1.3 minus 1.6, and then divide by negative 2. But if you divide by negative value, you should flip signs, and finally you get that t is greater than 0.65 and less than 0.95. And hence we can make the next conclusion. So when t is greater than 0.65 and less than 0.95 hours, height is less than 300 meters, and distance between them must be greater than 10 kilometers. But we know that distance between them is less than 10 kilometers only in this interval, so it means for other moments of time distance is greater than 10 kilometers. So for this interval, distance between them is greater than 10 kilometers. And for other time intervals, height will be greater than 300 meters. So for this time interval, when distance between them is less than 10 kilometers, height between them is greater than 300 meters. But if height is greater than 300 meters, it doesn't matter distance between them. So the two conditions are never broken at the same time, so regulations are not broken. So not broken. And here this distance in difference in height is greater than 300 meters, so also not broken. The next. A new coordinate system xy is defined with an origin R at 0.2 kilometers directly above the air traffic control tower. So there is tower, which is origin, and R is 2 kilometers above point R, and this R is a new origin. When an aircraft is flying in the horizontal plane containing R, the values of x and y represent its displacement in kilometers east and north on point R respectively. So x and y. A force aircraft D is flying at a constant height of 2 kilometers near the airport while waiting for permission to land. Its position at time t is given by RD. It's actually our position vector at any moment of time. Is given by 6.4 cosine of 38t and 6.4 sine of 38t. F. Describe the path followed by D. You can see that definitely it's not a straight line. To be a straight line, it must be what R is what position vector of any point plus parameter and velocity vector, so sine cosine cannot be present, and actually what paths can be in general. Definitely it's not a triangular or helix or elliptic or something like that. it's a circle. Why it's a circle? It's similarly to the unit circle. You can see that at any moment of time we get the same angle alpha, for example here, and what is 6.4? 6.4 is distance from the origin, and cosine alpha it's x coordinate, and the same. It's very important that these distances are the same. So sine multiplied by sine, it gives y coordinate, and it's true for any moment of time. So it's a circle. Or if we square x and y coordinates and add them up, we get the next 6.4 squared cosine squared 38t plus 6.4 squared times sine squared 38t, and it is equal to it's what, x coordinate plus y coordinate, and it is equal to what, 6.4 squared. Why? Because we can factor out 6.4 squared and cosine squared plus sine squared, all the same angle. It's the main trigonometric identity, it's 1. And comparing with x minus a squared plus y minus b squared is r squared. It's equation of a circle. So the path is a circle with center at 0, 0 at the origin. I mean with respect to r, not power, to r, because we consider two-dimensional motion at this plane, which is through the r and 2 kilometers above the tower. So center is at 0, 0, and radius is 6.4, or center at r, at point r with coordinate 0, 0, and radius is 6.4. And the next, around the same time, a small aircraft E is flying at the same height as D and along the line with vector equation. So it is given RE. It is given RE. It's position vector, and it's 20 and 10 plus lambda -1 and 1. So D is moving in a circle and RE is moving in a line. I don't know where this line is exactly, and it doesn't matter here. Let it be somewhere here. So it's line in which this E is moving. G, let B, vector B, be -1 and 1. I find RE dot product B. What is B? B, it's a direction vector of the aircraft E, and RE dot product B becomes, we can rewrite RE in the form 20 minus lambda, 10 plus lambda dot product -1, 1, and formula is given in the data booklet. It's x coordinate multiplied by x coordinate plus y coordinate multiplied by y coordinate, and it becomes 20 minus lambda plus -1 multiplied by 10 plus lambda, which is 20 minus lambda minus 10 minus lambda, and it becomes 10 minus 2 lambda. So it's RE dot product B in terms of lambda. 2 marks. Then next, hence find the value of lambda for which the distance from R to the line is minimum 2 marks. So if we consider, and we know that the distance is always the closest distance of the perpendicular distance, and what is RE? RE is a position vector of E at any moment of time, and B it's a direction vector of E, and RE position vector to be perpendicular. We can see that dot product is 0, so E will be at the closest distance to the origin R when dot product is 0, so we should equate dot product to 0, and we can see it happens when parameter lambda is 5 hours, or just 5. Then next, find the minimum distance 2 marks, and we know RE vector, and it's RE as a vector, it's 20 minus lambda, 10 plus lambda, and we need just the distance of this vector when R is 5. So it becomes, for lambda is 5, it becomes magnitude of the vector 20 minus 5, and or let's rewrite RE as a vector at when lambda is 5, it becomes 15 and 15, and the magnitude or length of this vector becomes square root 15 squared plus 15 squared, which is 15 root 2, or it's 21.2 to 3 significant figures kilometers. So it's 21.2 kilometers. And the last question shows that D and E will not break the air traffic regulations for any value over T, 2 marks. Notice that or actually we can see that the closest possible distance OE to the origin is 21.2, but since D is moving in a circle, this distance is 6.4, and we can see that the least possible distance between them, or the smallest possible distance between planes is 15 root 2, or 21.2 minus 6.4, which is greater than 10 kilometers, and it means that the distance is always greater than 10 kilometers, and the difference in height in general doesn't matter if the distance between them is always greater than 10 kilometers. Hence they do not break regulations. And that's all for this question.